One here. Okay.
Hello.
Hello, JB.
Yeah, how are you
JB,
doing? Can you hear me?
yeah, I can hear you.
Okay.
Can you hear us as well?
Yes, I think it's
Can you
clear.
hear us? All right. I learned today you'll be teaching the form the
Sorry,
basic nine, right?
sorry, can you repeat that, please?
Can you hear me?
Yes, I think it's a little laggy, so
I was saying I learned you'll be teaching the basic nine class today.
I think that is next time because
I put my phone further.
I think today we'll stick with the science lessons. And maybe starting in next week or 2 weeks, we will go into maybe like practicing the BECE test, which the ninth graders need to take later to attend high school. So um, I think for today we will stick with
All right, so today is it basic nine?
yeah,
Uh-huh.
this is a science lesson today. So and yeah, today I will not be presenting,
All right,
and
all right.
another student from school named Summer. So yeah,
Hi.
everyone please welcome her, and she will be doing the present teaching for today about electric and magnetic fields. So
Yeah. I'm gonna share my screen. Sorry. Oh no. I don't think I can share screen on my end.
Yeah, JB, I was asking that you wanted you
um,
wanted to teach the basic nine today, right? Because I've asked them to sit up for the lesson. That's for the basic nine.
uh, sorry, can you repeat that? I couldn't hear it. Right. Oh,
Okay. Did you see what he said?
yeah, so um, for that, I think you are talking about how we sort of decided to practice the BECE test, but we will not be doing that today. Um, Today is just going to be a regular science lesson. And
Okay, so I was asking that is it going to be for the basic nine or I have to stick with the old class, the basic seven and the basic eight?
yeah, if you can call them as well, that would be
Because
great.
at the moment the basic seven and eight are not with us.
Okay. Yeah, can you call them in as well so we have more people?
Okay,
Yeah, okay, thank you.
all right. Hello, Jamie.
Yes.
Jamie. Hello.
Yes.
Hello.
Can you hear me?
Yes, I can hear you.
Yes, so we are in now. The basic 7 and 8 matters.
Okay. Yeah. So I think Summer can start now, but you mind maybe introducing yourself a little bit before you start?
I'm sorry, were you talking about me?
Yeah. You can maybe give
Yeah.
a brief introduction. Yeah.
Okay, so hi everyone. So I go to the same school as Javen, and my name is Summer. Um so I will be teaching you about electric and magnetic fields today. Let me share my screen real quick. Is everyone able to see the slides? Yeah. Is everyone able to
They
see
were
the
saying that,
slide?
how are you doing? But I didn't hear them.
Oh, sorry. Yeah, I'm doing well.
Okay, all right. Yeah,
Okay.
so we can proceed.
Is everyone
Maybe
ready
we can
for
proceed,
me?
okay?
I'm sorry. What did you say? Oh, okay. I'll be able to see. So, is everyone ready for me to start the presentation? Okay.
Yes. Are you ready? Yes.
So first things first, I'm going to be talking about what electricity is, just for some context. So electricity is basically the flow of tiny particles called electrons, and electricity is used in many things, such as lightning, and people often often use electricity to watch television, like for example, plugging the TV into an electrical outlet, and also using a phone or computer, um, which is what I'm using right now to give the presentation, and also playing like different instruments such as an electric guitar. And here's a few examples of what I said. So to the top right is an example of lightning. Um, and then below that is an electric guitar, and below that um is a TV. And electricity is used in many different fields. And then a couple of the fields that electricity is used in is in electric fields and magnetic fields, which is what we will be discussing today. And just like to give some background about these fields, I have a video. Is everyone able to see the video? And also if any of you like need to write any of this information down, I can go back. I should have done that earlier. Okay. I'll give 30 more seconds um for you all to write down the information, and then we'll move on to the video. Okay. All right. So I think everyone is able to see my slides. So yeah, the video covered a lot of interesting things, and so I'm going to go a little bit in depth about electric fields and magnetic fields. And so the definition of an electric field, as the video has stated, is a region of space around an electrically charged particle or object in which an electric charge would feel force. And here's an example of something that uses an electric field. And so this image at the top right is called a transmission tower. And this helps transfer electric power from one like electrical station to another electrical station, before it reaches people's homes. And a magnetic field is an invisible force field that's caused by a magnet. It's also caused by moving electric charge, spinning electrons, and changing electric field. And for for example, magnetic fields are often used by different magnets, including bar and horseshoe magnets. And here's an example um, of something that uses a magnetic field. So the Earth, um, and you might have seen this magnet that's labeled SN in the video. It stands for south and north. In the Earth, in its core, it generates a magnetic field, which it pulls other things down to its core. Other examples of magnetic things that consist of magnetic fields are um, vacuums. Um, and also magnetic fields can be found in the air, and also, of course, magnets, which were shown in the video. Okay, I'm gonna give you all some time to write this down. Okay, I see that some of you are done, so I'm just gonna give about 15 seconds for the remaining of the people to write down. Okay. Is everyone ready? Okay. So first, we're going to be talking about electric fields. So electric fields, as I said before, are caused by electric charges, and electric charges produce electric fields. And an electric charge can be positive or negative. Um, and it's a property of matter that causes two objects to either attract or repel. In the Veda, I know the video talks about this as well. And if objects are oppositely charged, they will attract. And if objects are similarly charged, they will repel. And so they attract or repel based on their orientation. So, for example, if um, there are two objects that have a different orientation, they will attract. Well, if there are two objects that have the same orientation, they will repel. And this isn't like necessary to know, but a unit of electric charge is called a coulomb. And so I'm gonna give, I think, about 20 seconds for you all to write down the rest of the information. I see there are people still writing stuff down, so I'll give just 20 more seconds.
After here, when you go down, when you become a
Okay. All is everyone still writing down?
Yes.
Okay.
Yes. Yes.
Okay. Okay, I'm going to move on now to the next slide. So here's an example of objects that are negatively and electrically charged. So I'm not sure if you all have heard of this, but atoms are basic units of matter that are made up of three types of particles. And these particles are electrons, neutrons, and protons. Um, Neutrons are not electrically charged, while electrons and protons are electrically charged, and they have a positive and negative charge. And here's like an idea of what they like an image, um, what they kind of look like. The X represents the electron, and the white circles represent the protons, and the black ones represent the neutrons. So I'll give about 30 seconds to write this down. Okay, going to move on to the next slide now. Again, this isn't necessary to know, but here's the formula of electric field, which is E equals F divided by Q, and E is the strength of the electric field, while F is the electric force, and Q is what is used to feel the electric field. So as the video stated, like objects are a lot of time attracted based on how large the electric field is. And so when there's more electric force, there's a higher electric field. And also, electric fields exist in all points of space, and they can be seen by bringing another charge into the electric field. And also, electric fields can be measured using arrows called vectors that have different directions and sizes. Okay. Now we're going to be moving on to magnetic fields. Um, So the force that causes a magnetic field is called a magnetic force, and this force can be found in magnetic substances. And when materials that have magnetic substances become attracted, kind of like how materials with an electric charge become attracted, they produce a magnetic field. So, for example, like what you've seen from the video, like the paper clips, which were made of iron, was attracted to the magnet, and so they created a magnetic force. Um, and other examples of magnetic substances include nickel, cobalt, and steel. And some examples of non-magnetic substances include aluminum, copper, lead, and brass. So kind of like how materials with the same orientation become negatively charged. Um, objects that when an object that has a magnetic force and an object that is non-magnetic is like put together, um they do not produce a magnetic force because they are made of different material. And here's an example of aluminum to the right bottom, and also the nickel to the top right is an example of a magnetic substance, while the aluminum is an example of a non-magnetic substance. I believe that it's okay to go on to the next slide. And this is actually the last slide. And it talks about what a magnetic field looks like. So in the image to the right, here's kind of what a magnetic field looks like. Um, so it has these lines It has a lot of lines around the magnet, and these lines are called magnetic field lines or magnetic lines of forces. And also magnetic fields are measured using vectors, which are arrows that have different directions and sizes. And here's like also spin axis, which is like the arrow that's pointing up in the middle, and then the arrow that's kind of diagonal is a magnetic axis. And so I'll give you a few seconds to write everything down. Maybe like, yeah, 15 more seconds. Okay. So that's all for the presentation. And if anyone has any questions, feel free to ask, either about the video or about the presentation. Does anyone have any questions about what they saw or?
Question.
So you understand everything. Hello. Do you understand? So you understand everything. So she can what? Ask questions now.
Yes.
Eh?
Yes.
All right. Hello. They said they don't have any question for now. So if you have any questions for them.
No, I don't have any questions.
Okay. Yes, it's questions time. And your people are saying you don't have questions.
Okay. Okay. I think if no one has any questions, that's all for the presentation. Thank you all for listening, and I'm just gonna stop sharing my screen. Jabin, if you have anything to say.
Yeah, thank you, Summer, for presenting today. Yeah, it was a really nice presentation, and I hope everyone was able to learn something today, especially about the electric and magnetic fields. And um, thanks. I have a few announcements. So, I think you guys prefer to take the BECE test, which is like I've heard that it's a test that you take to get to high school. So this is for the ninth grade class. Um, so do you want to maybe practice some task questions for the test, or maybe do you want to continue the science lesson? Do you have any preference for that? So you can either continue doing these science lessons, or we can move on to solving some practice questions to prepare for the exam.
Questions? Okay, JB, they said they prefer to solve the past questions.
Well, okay. And I think starting from next week, we can maybe start solving some practice questions.
Okay. So starting from next week, you be starting what? Solving past questions. And hello, Jabin.
Yes.
Please, which subject will you be doing on next week?
Subject. We can practice either English or science, or math. Do you have anything you want to focus on?
Is he having all the questions? Have you given? Okay. Oh, okay. So since you have them, you go through them, you can choose one subject for next week so that we'll tell them. Okay. Then which one do you guys prefer on next week? Which subject? Sorry. Okay, David, please, they choose science on next week.
Okay, I think we can prepare for science questions next week. So, okay.
David,
Yeah.
we're saying that they want to solve past questions on Ghanaian language. Can you do that for them?
Sorry, can you repeat that?
On Chi. Can you do that? Hello?
Sorry, can I do what?
Yeah, I mean on Chi, Ghanaian language. One of the subjects is Ghanaian language. So they were trying to say that, can you do past questions on Ghanaian language for them?
Oh, I don't know too much about Ghanaian language. If they want to do it, yeah. Sure. But
Yes, they are joking. They are just joking. That one is not
Yeah.
part.
okay, yeah.
Yeah.
So, if you don't have any questions, for me or for Summer, yeah, then I'll see all of you next week, and we can solve more science questions. Okay.
Yes.
Yes.
So I hope that is so. Next week, say you'll be talking about science BC questions, right?
Yes. The science BECE questions.
Okay, all right. Okay, so all right, thank you. So yesterday, Sir Prince sent you some questions. Have you gone through it?
Yeah, I think we will go through that together. And yeah, I have practice questions downloaded from yeah, Prince sent us practice questions, so we will solve those together.
All right. All right. Thank you. Okay.
Yeah, sounds good. And I'll see everyone next week. So
Don't keep quiet.
All right. Bye.
Okay. Please, is that okay?
okay, yeah, bye everyone. And thank you, Summer, again for presenting
Yeah.
today.
Bye. Bye, everyone. Have a great day.
Bye.